For most of human history, we thought we were the center of everything. The universe revolved around us. The stars were lights fixed to a dome. The planets were gods wandering through the sky. Our place was certain. We were special. We were the point. But in the last 400 years, something happened. We kept looking. And every time we looked deeper, we got smaller. First, Earth moved from the center of the solar system to just another rock orbiting an ordinary star. Galileo pointed his telescope at Jupiter in 1610 and saw 4 moons orbiting another world, proof that not everything revolved around us. Then our sun turned out to be one of hundreds of billions of stars in the Milky Way, and even our galaxy, once thought to be the entire universe, became just one island among many. Today, we know there are at least 2 trillion galaxies. We are not at the center. We are not even close. We are standing on a speck of dust orbiting an ordinary star in the suburbs of an ordinary galaxy, in a universe so vast that the numbers stop meaning anything. But here is the strange thing. The more the universe shrinks us, the more it connects us to itself. Every atom in your body came from somewhere. The hydrogen in your cells was born in the Big Bang. The carbon in your DNA was forged inside stars. The oxygen you are breathing right now was created in stellar cores. The iron in your blood is the ash of dead suns. You are not just living in the universe. You are the universe, arranged into a temporary pattern that can think about itself. And the universe spent 13.8 billion years making you. That is what this video is about. Not just what is up there, the galaxies, nebulae, planets, stars, and questions breaking modern physics, but what it means for you down here. By the end, you will know what you can see tonight with your own eyes. You will understand why modern cosmology is being challenged. You will learn why you are literally made of stardust. And you will find a free beginner guide in the description that brings the journey together. Basic stargazing tips, simple telescope guidance, links to deeper cosmic books, and a cosmic identity section connected to the zodiac. This is your place in the universe. And we start now. Most of us have never truly seen the night sky. We have glanced at it, sure, a few dots between buildings. Maybe a bright planet if we look up from our phone long enough. Maybe once, on a camping trip far from the city, we tilted our head back and thought, wow, that is a lot of stars. But the real sky, the one our ancestors knew, is hidden behind city lights, concrete horizons, and screens pointed toward our faces instead of upward. There are places on Earth where the sky still looks ancient. In the Atacama Desert in Chile, the air is so dry and the altitude so high that the night sky almost does not look real. The Milky Way stretches from horizon to horizon like a river of light. In the darkest places, it can be bright enough to cast a faint shadow. You can see dark patches inside the Milky Way, not empty spaces, but giant clouds of dust blocking the light of billions of stars behind them. The Inca saw these dark regions as constellations too, not patterns made of stars, but patterns made of darkness. The large and small Magellanic clouds hang in the southern sky like pale smudges of spilled milk, 2 small galaxies orbiting our own. If you stood there tonight and looked up, you might see around 4,500 stars with your bare eyes. That sounds like a lot. But the Milky Way contains between 100 billion and 400 billion stars. The stars you can see with your eyes are only the closest neighbors, mostly within about 1,000 light-years of Earth. The Milky Way is about 100,000 light-years wide, So everything you have ever seen with your naked eye is just a tiny bubble inside our own galaxy, and our galaxy is one of 2 trillion. The human brain was not built for this. It evolved to track movement in grass, recognize faces, find food, avoid danger, and survive a few square miles of land. It did not evolve to understand a universe where the nearest star is 4.2 light-years away, and the most distant galaxies we can observe sent their light toward us more than 13 billion years ago. But we try anyway. That is what makes us human. We look up and ask, how far? How old? How big? Why? In 1990, Voyager 1 was 6 billion kilometers from Earth, leaving the solar system. Carl Sagan convinced NASA to turn the spacecraft's camera back toward home one last time. The result became known as the pale blue dot. Earth appeared as a single pixel. Everything we have ever known was there. Every person, every war, every love story, every civilization, every memory, every dream. 1 pixel. A mote of dust suspended in a sunbeam. That is where every journey into space begins. Not with equations, not with galaxies, but with this dot. Our only home. Every journey into space begins the same way. Feet on the ground, eyes on the sky. You do not need a telescope to start. You do not even need expensive equipment. The truth is, the night sky begins with patience, a dark place, a clear night, eyes adjusted to the darkness, and the willingness to look up for more than a few seconds. Light pollution is the first enemy of stargazing. Cities and streetlights create a glow that hides most of the stars, galaxies, and nebulae. If you want the best experience, you need to find the darkest place you can reach. A backyard outside the city, a local park, a rural road, or an official dark sky location. Timing matters too. A bright full moon can wash out the sky like a giant flashlight. For deep sky objects, the best nights are around the new moon, when the sky is darkest. And your eyes need time. It can take 20 to 30 minutes for your night vision to fully adjust. One glance at a bright phone screen can ruin it. Experienced stargazers use red light because it helps them see charts and equipment without destroying their dark adaptation. This is where the free beginner guide linked in the description can help. It gives you the basics of getting started with the night sky, how to prepare, how to choose a darker location, why the moon phase matters, how to adjust your eyes to the dark, and what simple objects to look for first. Because astronomy does not begin with owning equipment. It begins with recognition. Still, if you want to go deeper, one tool changes everything: a telescope. Galileo did not invent the telescope, but in 1609 he did something no one had truly done before. He pointed it upward. By modern standards, his telescope was primitive. It magnified about 20 times. A cheap pair of binoculars today can outperform it in many ways. But through that crude instrument, Galileo saw mountains on the moon, the phases of Venus, and 4 moons orbiting Jupiter. That changed everything. It showed that the moon was not a perfect heavenly sphere. It was a world with mountains and shadows. It showed that Venus orbited the sun. And it showed that not everything revolved around Earth. One small telescope helped collapse a worldview that had lasted for nearly 2,000 years. Today, even simple equipment can open the sky in a way that changes how you see your place in the universe. With binoculars or a small telescope, you can see the moon in detail. With a beginner telescope, you can see Jupiter's moons. With a stable setup and good conditions, you can see Saturn's rings. And under dark skies with enough aperture, you can begin to see nebulae, star clusters, and even galaxies. But beginners often get overwhelmed. Refractors, reflectors, Dobsonians, mounts, eyepieces, focal ratios, aperture sizes. It can feel like you need to become an engineer before you can look at the moon. You do not. For a beginner, 3 things matter most. First, aperture. Aperture is the diameter of the main lens or mirror. Bigger aperture gathers more light. More light means fainter objects become visible. A small telescope can show the moon and bright planets. A larger one opens more of the deep sky. Second, mount stability. A wobbly mount can ruin even good optics. If the view shakes every time you touch the focus knob, you will stop using the telescope. Third, ease of setup. The best telescope is not the most expensive one. It is the one you actually use. A simple telescope you use often is better than a complicated one that stays in a closet. That is why the free beginner guide linked in the description includes simple telescope guidance. It explains the basic ideas beginners should understand before choosing their first telescope. What aperture means, why stability matters, why setup affects how often you actually use it, and why cheap, shaky equipment can make the experience frustrating. The first telescope is not just a purchase, it is a doorway. Most people think astronomy begins with expensive equipment. It does not. It begins with the moment you point your eyes, binoculars, or a telescope at the sky, and realize that those lights are not decorations. They are places. The moon teaches you that other worlds have landscapes. Jupiter teaches you that Earth is not the only center of motion. Saturn teaches you that beauty can be physically real, not symbolic, not imagined, but made of ice and gravity. And the deep sky teaches you patience, because galaxies and nebulae do not explode into view like edited NASA images. They appear slowly, a faint smudge, a soft glow, a shape that only becomes visible when your eyes relax and your mind stops demanding instant results. The goal is not just to own equipment. The goal is to build a relationship with the sky. Now let us talk about what you can actually see. The moon is the obvious first target, and it remains the best one. Through a telescope, the moon stops being a flat disk of light. It becomes a world. The best place to look is the terminator, the line between lunar day and lunar night. Along that border, shadows stretch across the surface, revealing mountains, crater walls, ridges, valleys, and ancient lava plains. Craters like Copernicus and Tycho become real places. Tycho's bright rays stretch across much of the visible moon, material blasted outward by an impact that happened when dinosaurs still walked the Earth. The moon is not decoration. It is terrain, a world. And you can see it tonight. Then there is Jupiter. To the naked eye, Jupiter looks like a bright star that does not twinkle. Through even a small telescope, it becomes a disk. Beside it, you can see 4 tiny points of light: Io, Europa, Ganymede, and Callisto, the Galilean moons. Night after night, their positions change. Sometimes one disappears behind Jupiter. Sometimes one crosses in front of the planet. You are watching worlds orbit another world in real time. With slightly better equipment and steady skies, Jupiter's cloud bands appear, dark belts and bright zones, a turbulent atmosphere, storms larger than Earth. The Great Red Spot, when visible, is a storm that has been raging for centuries. And then there is Saturn. Most amateur astronomers never forget the first time they see Saturn's rings. Not in a photograph, not in a documentary, but live, through their own telescope. Those rings are not solid. They are billions of particles of ice and rock, each one following its own orbit around the planet. The rings span hundreds of thousands of kilometers, but in many places they are only about 10 meters thick. If Saturn were the size of a basketball, the rings would be thinner than a sheet of paper. That is the kind of thing a telescope does. It turns facts into experience. But you do not need to begin with a telescope. You can start with the naked eye. Find the Big Dipper. Use the two stars at the edge of its bowl to point toward the North Star. Learn how the sky moves. Notice that Venus, the evening star, is not a star at all, but a planet shining in the twilight. Watch how the constellations change from season to season, because Earth is orbiting the Sun. The sky is not a static ceiling, it is a moving map. Beyond the planets, the deep sky opens. The Orion Nebula, Messier 42, is a stellar nursery about 1,344 light-years away. Through a backyard telescope, it appears as a soft grey-green cloud surrounding a tight group of bright stars called the trapezium. Inside that cloud, new stars are being born right now. The light entering your eye left the nebula more than 1,000 years ago. The Pleiades, the Seven Sisters, is a cluster of hot blue stars about 444 light-years away. With the naked eye, you may see 6 or 7 stars. Through optics, you see many more. They are young stars, born from the same region of space, still traveling together before they eventually drift apart. And then there is Andromeda. The Andromeda galaxy is about 2.5 million light-years away. It is the most distant object visible to the naked eye under dark skies. The light from Andromeda began traveling toward Earth before humans existed. When those photons left Andromeda, our ancestors were still learning to shape stone tools. Then that light crossed intergalactic space, entered the Milky Way, passed through Earth's atmosphere, through your telescope, and ended its journey on your retina. That is not a picture. That is not a simulation. That is real light from another galaxy touching your eye. Once you experience that, you stop just looking and you start asking, how did all of this begin? For most of human history, the answers were myths, religions, and stories. Every culture had a creation narrative. The sky was filled with gods, monsters, spirits, and signs. But then we built instruments, and the universe started answering back. The standard story says that 13.8 billion years ago, the universe was extremely hot, dense, and compressed. Then space itself began expanding. This was not an explosion into empty space. It was the expansion of space. In the first fractions of a second, the universe grew unimaginably fast. In the first few minutes, the first atomic nuclei formed, mostly hydrogen and helium. For hundreds of thousands of years, the universe was too hot for atoms. Light could not travel freely. Everything was a glowing plasma. Then, about 380,000 years after the Big Bang, the universe cooled enough for atoms to form. Light was finally released. We still see that ancient light today as the cosmic microwave background, the afterglow of the Big Bang. From there, the standard model of cosmology tells a story of gradual structure. The first stars formed. They lived fast and died violently. Their explosions created heavier elements. Galaxies assembled over time. Dark matter provided the invisible gravitational scaffolding. Dark energy drove the accelerating expansion of the universe. The model was powerful. It explained a lot. It matched many observations. Then came the James Webb Space Telescope. And the reason Webb matters so much is not only that it is powerful, it sees the universe differently. Hubble changed astronomy by seeing visible and ultraviolet light with incredible clarity. But Webb was built to see mostly infrared light, the kind of light stretched by the expansion of the universe. As the universe expands, light from the earliest galaxies is stretched into longer and longer wavelengths. By the time it reaches us, ancient starlight has shifted into infrared. That means Webb is not just looking farther away. It is looking further back in time. One of Webb's first public images showed the galaxy cluster SMACS 0723. At first glance, it looks like a field crowded with stars. But most of those points and arcs are not stars. They are galaxies, thousands of them. Some distorted into curved streaks by gravity itself, because the mass of the foreground galaxy cluster bends and magnifies the light behind it. That effect is called gravitational lensing. It means the universe can become its own telescope. A massive galaxy cluster can bend space enough to magnify objects behind it, letting us see galaxies that would otherwise be too faint and too far away. So when Webb looks into deep space, it is not only using a mirror made by humans, it is also using gravity, the architecture of the cosmos itself. And this is why the early universe is suddenly full of surprises. Webb is not replacing the old story overnight. Science rarely works that way, but it is adding pressure. It is showing us galaxies that seem brighter, heavier, or more mature than expected. It is forcing cosmologists to ask whether stars formed faster, whether black holes grew earlier, whether dust behaved differently, or whether some part of the model is still missing. That is what makes this moment historic. We are not watching the end of cosmology. We are watching cosmology become interesting again. JWST launched on December 25, 2021. It took decades to build, cost billions of dollars, and was designed to see deeper into cosmic history than any telescope before it. Its mission was to look back toward the earliest galaxies. The expectation was simple. Webb would find small, young, messy galaxies slowly forming in the cosmic dawn. But what it found was surprising. Some of the earliest galaxies appeared too bright, too massive, and too structured for their age. They seemed to exist too early. It was like looking into the childhood of the universe and finding adults. This does not mean the Big Bang is wrong. It means the story may be incomplete. Galaxy formation may have happened faster than we thought. Or the early universe may have behaved in ways our models do not yet fully capture. Then there is the Hubble tension. Scientists measure how fast the universe is expanding in two main ways. One method uses the ancient light of the cosmic microwave background. It gives one number. Another method uses stars and supernovae in the modern universe. It gives a higher number. The two measurements do not agree, and the disagreement has not gone away. That means either something is wrong in the measurements, or something is missing from the model. And then there is dark matter. We cannot see it. We cannot touch it. But galaxies behave as if it is there. Without dark matter, galaxies should not rotate the way they do. The cosmic web should not have formed the way it did. For decades, physicists have searched for dark matter particles. So far, nothing. No direct detection, no confirmed particle, only gravity pointing towards something invisible. This sounds like science is failing, but it is the opposite. This is science working. Science advances when the universe refuses to match our expectations. The cracks in the model are not failures. They are doors. And somewhere beyond those doors may be the next great revolution in physics. But what does any of this have to do with you? Everything. Because all of this, the Big Bang, the first stars, the exploding supernova, the formation of galaxies, the birth of planets, produced you. The hydrogen in your water is ancient. It came from the beginning. The carbon in your DNA was made inside stars. The oxygen in your lungs was fused in stellar cores. The iron in your blood came from the death of massive stars. There are roughly 7 octillion atoms in your body. Every one of them came from somewhere else. You are not separate from the universe. You are a temporary arrangement of cosmic material, organized into a pattern that can look back and ask where it came from. That is not poetry. That is physics. And if you want to go deeper into that story, the free guide in the description also points you toward the cosmic books. Deeper reading on the map of the cosmos, the future of space, consciousness, and what it means to matter in a universe this old and this large. The guide gives you the starting point. The books take the journey further. If the universe can produce us, conscious, self-aware, curious, then the next question is obvious. Are we alone? In 1961, astronomer Frank Drake created an equation to estimate how many communicating civilizations might exist in the Milky Way. It considers how many stars there are, how many have planets, how many planets could support life, how often life begins, how often intelligence evolves, how often technology appears, and how long civilizations survive. Even with conservative assumptions, the numbers suggest there could be many civilizations in our galaxy. Maybe thousands, maybe millions. So where is everybody? That is the Fermi paradox. If intelligent life is common, why have we found no clear evidence, no signals, no visitors, no artifacts, no confirmed contact? There are many possible answers. Maybe life itself is rare. Maybe intelligent life is rare. Maybe technological civilizations destroy themselves before reaching the stars. This is called the Great Filter. The idea that somewhere between chemistry and interstellar civilization there is a barrier most species do not survive. Maybe the filter is behind us. Or maybe it is ahead. Another possibility is the zoo hypothesis. Advanced civilizations may know we are here, but choose not to interfere. Maybe Earth is being observed, but not contacted. Or maybe we are early. The universe is 13.8 billion years old, but stars and planets will continue forming for trillions of years. Maybe we are among the first intelligent beings to appear. Maybe the silence is not a warning. Maybe it is an invitation. While philosophers debate, scientists are looking, and this search is no longer science fiction. It is now an observational science. For most of history, we did not know whether planets existed around other stars. We assumed they probably did, but we had no proof. Now we know planets are everywhere. Some stars have giant planets orbiting so close that their years last only days. Some have rocky planets packed into tight systems. Some have worlds in the habitable zone, where temperatures could allow liquid water to exist on the surface. The more we look, the less special our solar system seems. And that is both humbling and thrilling, because if planets are common, then chemistry has many places to experiment. If water is common, then oceans may not be rare. If organic molecules are common, then the ingredients for life may be scattered across the galaxy. The question is no longer, are there planets? The question is, what happens on them? Europa is one of the most important places in that search. Beneath its ice, there is strong evidence for a global ocean, not a small pocket of water, an ocean world. NASA's Europa Clipper mission was designed to study whether Europa has conditions that could support life. It will not land and dig into the ice. It will fly by Europa again and again, measuring its surface, its chemistry, its ice shell, and the environment around it. That is a different kind of exploration. Not planting a flag, listening, sampling, asking whether an ocean hidden under ice might be alive. And beyond our solar system, exoplanets turn the question cosmic. If even one world around another star shows strong evidence of life, the meaning of the universe changes. Life would no longer be something that happened once, on one small planet, by impossible chance. It would become a process. Something the universe does when conditions are right. Mars may once have had lakes and rivers. The Perseverance rover is exploring Jezero Crater, an ancient lakebed, searching for signs of past microbial life. Europa, one of Jupiter's moons, has a global ocean beneath its icy crust. There may be more liquid water there than in all of Earth's oceans combined. Enceladus, a moon of Saturn, sprays water from its subsurface ocean into space. Cassini flew through those plumes and detected salts and organic compounds, ingredients that matter for life. And beyond our solar system, we have confirmed thousands of exoplanets orbiting other stars. Some are gas giants, some are rocky worlds, some orbit in the habitable zone where liquid water could exist. One of the most interesting worlds is K2-18b, a planet about 120 light-years away. Observations have suggested molecules in its atmosphere that make scientists pay attention, including possible biosignature candidates. The detection is not confirmed. It may not be life, but it is the kind of maybe that keeps astronomy alive. The universe may be silent, or we may simply not have listened long enough, and all of this can feel overwhelming. The distances, the numbers, the silence. The possibility that somewhere out there, something may be looking back. So for thousands of years, humans have asked another question. Not only what is out there, but what does it mean for me? That is where the zodiac comes in. The 12 zodiac signs trace back thousands of years to ancient sky watchers who mapped the path of the sun through the constellations. They connected the movement of the heavens to human life, personality, timing, and meaning. You can see astrology as astronomy's poetic cousin. You can see it as symbolic language. You can see it as one of humanity's earliest attempts to connect the outer universe with the inner world. The point is not to replace science. The point is connection. Science tells us what the stars are. Myth, symbol, and astrology ask what the stars mean to us. That is why the free beginner guide also points you toward a cosmic identity section connected with the zodiac, a more personal way to connect the sky above you with the story inside you. The guide is a starting point for the journey in this video. Basic stargazing tips, simple telescope guidance, links to deeper cosmic books, and a personal cosmic identity path through the zodiac. One guide, one link, in the description. So what do you actually do with all of this? 2 things. One you do tonight. One you do for the rest of your life. Tonight, walk outside, even without a telescope. Even if you live in a city, find the darkest place you can. A backyard, a park, a balcony, a quiet street away from direct lights. Put your phone away. Let your eyes adjust and look up. Find the moon first, even if it is just a crescent. Remember that the shadows along the Terminator are mountains and crater walls on another world. You are looking at a landscape no human has walked on since December 1972. The last footprints on the moon are still there. No wind, no rain, no erosion. They may remain for millions of years. Then find a bright point of light that does not twinkle. That is probably a planet. Maybe Venus, maybe Jupiter, maybe Saturn. You are not looking at an idea. You are looking at a place. Venus has a crushing atmosphere and surface temperatures hot enough to melt lead. Jupiter has storms larger than Earth and moons with oceans beneath ice. Saturn has rings made of billions of pieces of ice and rock. These are real worlds moving through space right now. Then find the faintest star you can see, the one that disappears when you look directly at it and reappears when you look slightly to the side. That light may have traveled for hundreds or thousands of years before reaching you. A photon left a star, crossed space, entered Earth's atmosphere, passed through your eye, and ended its journey in your body. One photon, one person, one moment. 13.8 billion years in the making. That is what you do tonight. For the rest of your life, stay curious. You do not need a PhD. You do not need a $10,000 telescope. You do not need to understand every equation. You need the willingness to look up and ask why. The people who changed astronomy began there. Edwin Hubble looked at Andromeda and proved it was not a nebula inside our galaxy, but another galaxy entirely. Overnight, the universe became far larger than we had imagined. Vera Rubin studied the rotation of galaxies and found that they spin too fast to be explained by visible matter alone. Her work helped reveal the mystery of dark matter. Cecilia Payne-Gaposchkin showed that stars are made mostly of hydrogen and helium, one of the most important discoveries in astrophysics. They were not born as icons. They were people who asked questions and refused to stop. That is the pattern. Look up, ask, keep going. The free beginner guide linked in the description follows that same path. First, basic stargazing, because you can begin tonight with your eyes, a darker sky, and a little patience. Second, simple telescope guidance, because the universe should not remain an idea. You should know the basic things that matter before you try to see the Moon, Jupiter, Saturn, Orion, or Andromeda through optics. Third, links to the deeper cosmic books and the cosmic identity section, because seeing is only the beginning. Human beings have never looked at the sky only for data. We have always looked for meaning too. That is the full path. See the universe. Understand the universe. Then find your place inside it. The universe is 13.8 billion years old. It spans at least 93 billion light-years. It contains around 2 trillion galaxies, each with billions of stars, many with planets, many of those planets worlds we have never seen. And yet, in all of that vastness, there is only one you. The hydrogen in your cells was born near the beginning of time. The carbon in your body was forged in stars. The oxygen in your blood was made in stellar fire. The iron carrying that oxygen came from the death of massive suns. You are not separate from the cosmos, watching it from a distance. You are the cosmos, arranged into a form that can wonder where it came from. The same universe that made the Orion Nebula made your thoughts. The same physics that shaped galaxies holds your body together. The same atoms that drift between stars are alive in you now. You are not just in the universe. You are the universe. And the universe is asking itself, through you, what is next? Thanks for watching. I will see you under the stars.